Okay, are we live? I believe we are. I don't know why I say that because I'm right there. I can see that. So hopefully it's working like it always does. Hello, everybody. Someone said they got a victory royale before the stream. Congratulations. I've always been bad at those kinds of games. I'm terrible at anything Fortnite or whatever. But yeah, anyway, ACT. We're going to be doing 10 practice problems to help you prepare. If you're watching this afterwards, hello, we're streaming this the night before. So everyone's all stressed and worried about the test. And so we're going to try to alleviate those worries a little bit by doing some practice problems. This is the best way to practice. How long do you think the stream will be? Well, it's 10 problems. I've done two of these before. The first one was an hour and the second one was over 2 hours. So I really don't know. But I mean, it just depends on how much people want to chat about the test, but it's going to be 10 practice problems. And we're going to go, we're going to go slow. We're going to go step by step because I really want to make sure that everyone understands. It's just going to be a chill stream. It's not going to be like super hard or anything, but definitely want to, do some challenging problems so that you guys are used to it for the test tomorrow. So if you're watching along right now live, if you want, you can like pull out a piece of paper and a pencil and try these problems out yourself. Try to go ahead of me and then see, what you did right, what you did wrong. Or if you're watching the replay of this, you can pause the video and try it first. Um, or, just watch and chill. That works too. Honestly, just being here in the first place shows that you're motivated and you want to do good on the test, and I think anything helps. The whole point is to just get you used to what an ACT problem looks like, right? Okay, so let's erase the greetings there. So this first problem, I put it there because I want to try to start with one of the easier problems, and this one is just so cheesable. I don't even know why this problem exists, but we have it anyway. So it says, which of the following lists, oh my gosh, I'm already reading it wrong. Which of the following, I can't read. Which of the following lists or I was reading lists as a verb. Which of the following lists orders 1/2, 0.43, 3/8, 0.35, and 2/5 from least to greatest? Now, I just want to apologize for everyone who's like me and is picky about fonts, and you're wondering why this is a different font from the rest. I don't know. It happens. I'm upset too. I don't know if anyone else cares, but I care. So, what is the best way to do this? Well, we don't even necessarily have to list them all out from least to greatest. If you want, you can just kind of eliminate answers. So the first thing I'm noticing is that A and B have 0.35 as the first one, but C and D have 3/8 as the first one. So our first question is which of those is smaller? Because we want the smallest at the front. So if we can figure out which one is smaller, we can eliminate two of the answers already. So there's two ways you can do this. You can think about it in your head logically, which is probably what they want you to do, or you can just pull out your calculator and we're going to find out what 3/8 is. Now, the key thing is that fractions are the same thing as division, right? So you have to know that going into it and putting it in your calculator. So you have to know that you're supposed to do 3 divided by 8 because fraction bar, division, same thing. And when we do that, we find out that 3/8 is equal to 0.375. So which is bigger, 0.35 or 0.375? Well, this is 0.37, just ignoring the 5, right? So 3.7 is bigger than 3.5. So as least to greatest, we want the least first. So we want 0.35 first. So that means that we can eliminate C and eliminate D. And now we're just down to a 50-50, right? Just on the first number. So what's next? Well, is there anywhere I can access the past ACT tests? I'm not sure about like past ACT tests, but what you can do is on the ACT website, they have two full-length practice tests. I don't know if you've seen those. They're probably old questions, I would guess. I doubt they wrote new ones just for the practice test. That seems like something they wouldn't do because like laziness and all that. But those are probably old questions. Those are probably the most helpful practice questions, even if there's not that many, just because they're official, they're from the ACT. So you know that they're very similar to what you'll see on the test. So That's what I would recommend, because those are probably old questions. Okay, the next two numbers in each of these are swapped as well, right? 2/5 and 3/8. So which one is bigger? Well, we already found out that 3/8 is 0.375, right? We put that in our calculator. And now you can do 2/5 as well. Now, you might already know what the decimal is for that, but you're also allowed to put it in your calculator. That's fine if you want to. 2/5 is 0.4. So which one of those is smaller? Which one should come first? Well, this one has less decimal places, but that just means there's zeros at the end, right? And 400 is bigger than 375. So 375 is least, and that needs to come first. So this one is wrong. It needs to be 0.35, then 3/8, then 2/5. And if you want just a sanity check, you can check the next two. 0.43 is bigger than 0.40, and 1/2 is 0.5. That's the biggest one here. So the answer here is B. I don't know why this question exists, guys. I don't get it. Like, it's just put things in your calculator. Does the ACT test? Oh my gosh, I can't speak. This is gonna be a long night. Does the ACT test change every month? Probably. I mean, I doubt they recycle questions, because then people could like start sharing the questions online, and stuff like that. So they probably write new ones every time. So yeah, I believe it changes. I can't imagine that it doesn't. But the types of questions that you see are probably going to be kind of the same. They have a breakdown of let's move on to the next problem. They have a breakdown of what categories are going to be on each test, and it's always the same number or like close to it. Like you're always going to have I don't remember the exact numbers, but like 8 to 9 algebra problems, and you're going to have this many geometry. That's always the same. And you do get an online calculator for the online test. Yes, you get Desmos, which is regular calculator and graphing calculator. So, yeah. And you're allowed to bring a graphing calculator as well, if you want to. There's not really a point. If you're taking the paper ACT, you'll want to bring one if you have one. You don't need one, though. If you don't have one, don't worry about it. But if you're taking the online ACT, then yes, you get Desmos. And I would recommend learning how to use it, even if it's just like spend 5 minutes learning what Desmos does. I do have a video on it, but you don't have to watch my video if you don't want to. Just learn it, because it may come in handy for a question. You never know. And questions on digital the same as paper? I'm not sure, but I would guess they are. It's the same rules, I believe. So they probably are the same questions, but I don't know for sure. Don't quote me on that. Okay, which of the following is equivalent to the inequality this? Okay, so this is kind of just a raw algebra problem, right? You're going to have some of these where it's not really a word problem, it's just, solving it. So how do we do this? Let's go ahead and write this down over here so that it's easier to work with. So I know that we have a weird sign. This is less than or equal to. The little line underneath means or equal to. But it's really just the same thing as if it was an equal sign. There's going to be one thing that's different, and uh, well, actually, it might not even apply here, but it doesn't matter. It's basically just the same as solving for X or solving for a letter. The fact that it's the letter N doesn't matter. Just any letter works. So how do we do this? Well, remember the goal is to isolate the variable, which is a fancy word for getting the letter by itself, getting N by itself on one side of the equation. And the biggest problem with that right now is that it's on both sides of the equation. So we need to get rid of one of those. And how do we do that? Remember that in algebra, you can do whatever you want to the equation as long as you do it to both sides. And then that keeps the equation true, right? So we have to get rid of one of these n's. And they're both being added. This is like an invisible plus sign, but they're both being added. So we need to subtract one of these out. You could subtract the 3n on both sides, but then you have 2 minus 3, and that's negative numbers. So I actually prefer to get rid of the 2n, because that avoids negative numbers. So we're going to subtract 2n on both sides. Now, the 2n's are going to cancel out, right? That's the point. All that's left is not 4, negative 4. Probably the most common algebra mistake is forgetting minus signs. So don't do that. The sign is going to stay the same. And the -7, we haven't done anything with that. Now over here, we have 3n minus 2n. So that's just 3 minus 2, which is 1. So you could write plus 1n, but there's no point in writing a 1 in front of a letter, right? Because it's already an invisible 1. Anything times 1 is itself. So we can just write the letter n. There's just one n. Okay, what's our final? We're already really close to getting n by itself. What's our final step? Well, our final step is to get rid of this -7. And the opposite of minus is plus. So we'll add 7 to both sides. So these cancel. On the right, we just have the letter n. The sign is still going to stay the same. And on the left, we have -4 plus 7. So if you wanted to, you could just put that in your calculator, but if you're confused about negative numbers, but remember that you're on a time crunch. So this is just how I always think of it, or how I would suggest you think of it, which is money. Think of it as losing money and gaining money. You lost $4, but then you gained 7 back. So in total, you are up $3 compared to before. So positive 3. So our final answer is that 3 is less than or equal to n, which seems a little bit weird and it looks like someone's pointing it out. Do we flip an inequality if we divide? Oh, yes. Yes, you do. I was going to say the only difference with inequalities is if you divide or multiply by a negative number, you have to flip it around to like greater than. But we didn't have to do that because we didn't divide or multiply by a negative number. But that is an important thing to know. Now, it may seem kind of weird because this doesn't look like one of the answers, right? I mean, there is a 3. But all of these are greater than, and I thought we didn't need to flip. Well, that's because n is on the right side, and the alligator is always going to chomp the same number, right? So if we want to flip this around and do n on the left and 3 on the right, then the alligator still has to be chomping the n because it's bigger than 3. So we do have to flip the sign around when we're flipping the inequality around. And we have n is greater than or equal to 3, and that's D. That was terrible. That's D. How do you find side lengths using sine, cosine, and tangent? I don't know if I have a problem on that this time. Uh, the way that you should remember it is SOHCAHTOA. So this is the one I'm trying to remember. I feel like there was in one of the other ACT streams we did a SOHCAHTOA question. I don't remember for sure. I'm trying to remember. Uh, Also the like geometry final exam video, like the very last question I think was that. So you can go look at that if you want. But yeah, so this is the acronym you want to use. It stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And if you're like, I have no clue what you just said, well, I mean, actually, it's not that bad. On the ACT, there's going to be like 1 or 2 trig questions. So if you've never taken trig and you feel like you're going to be overwhelmed trying to learn it for 1 or 2 questions, then I would say don't worry about it. But if you're like, like above 30 already and you're trying to make sure you have every question down, then maybe, and you haven't taken trig, then I would suggest taking a look at it. It's actually not that bad. It's not that bad. It's just so different from I don't know why they decided that they want to put some trig questions on the ACT, like just 1 or 2. Like it doesn't even make sense. I'm taking my test on computer. Should I watch videos and work on how to use Desmos? I would say, yeah, that would definitely help. Learning how to use Desmos. I always just say like, it's not that important. It's not going to save you. And honestly, most of the problems, Desmos isn't helpful. But if you do have access to it and you have 5 minutes of spare time, I would suggest looking at how to use it because there could be a couple of problems where you're like, man, I really wish I had Desmos right now, and it's good to know how to use it. So, uh, yes, it's the geometric sequence problem, the dreaded problem. But yeah, Desmos definitely helps. And watching videos, especially if you pause before each question and try to do it yourself. That is the best way to learn. I'm gonna panic so hard tomorrow. Nah, I don't think because I know you're allowed to bring like a stopwatch for timing yourself on the test day, but I don't think I did that when I took because I took the SAT. I don't think I did that. I just relied on the person saying, how much time we have left. uh, you know, it's not the end of the world. It's not like knowing how much time you have because you also don't want to be constantly looking at how much time you have left and like stressing out about it, you know? I mean, as much as I love a good stressing out, it's not very helpful for taking a math test. So, just try to get in a flow state. And if you don't know an answer, move on and just make sure you've got the problems down. Is there a calculator in Desmos? Yeah, it is a calculator. So Desmos is regular calculator and graphing calculator, I believe. Because I believe it would give you a regular calculator as well if you're taking the digital. Uh, yeah. Okay. So here we have a geometric sequence problem. And you're like, what does that mean? What does that mean? Well, let's find out, right? It says if 2 is the first term of a geometric sequence and 128 is the fourth term, which of the following is the second term? So even if, like, let's say you didn't know what a geometric sequence was, right? One of the key skills you can have on the ACT is just using context clues. If there's a word like geometric sequence that you don't know what that means, like you don't remember ever learning it, you can kind of try to figure out based on the context of the problem, what could a geometric sequence mean? Like, what is it asking us to do? And even looking at the possible answers. So if we're just going from the first term to the fourth term. So there's some sort of sequence. The first term is 2, and then there's the second term and the third term, and then the fourth term is 128. And you're like, how did we get so high up to 128 so fast? And you'll also notice the answers are all even numbers, like divisible by 2. So it seems like it's suggesting that we're going to be multiplying by something, because the only way you get to a number this big is by multiplying something over and over. And that actually is the definition of a geometric sequence. It's multiplying by the same number over and over to create a sequence. Like if you were multiplying by 2 every time, it would be 2, 4, 8, 16, 32, 64, so on. But we're going even faster than that. So already we're probably not multiplying by 2. Now, I feel like the best way to do this will probably be to maybe test out each answer, right? So let's test out A. If A was 4, then how do we get from 2 to 4 using multiplication? Well, you multiply by 2, right? 2 times 2 is 4. Now let's test that out all the way. 4 times 2 is 8. Times 2 is definitely not 128. So 4 is not the answer, right? 4 is definitely not it. Let's keep going, right? Let's test out 6. Let's say 6, because remember, I guess I should have stressed this more. It's asking us for the second term, right? That is the goal in our problem. We want to find this right here. So that is our goal for this problem. I always suggest, like, if it's like a long problem, skip ahead to what it's asking you to find. And then with that in mind, look at the rest of the problem. Is there like a formula for these questions? There is, but it's not that helpful. I'm trying to remember what letters they use. It's like um I don't know. It's a bunch of random letters. It's like R to the R to the T um something like this. Like yeah, I don't know. Honestly, the formula is not that helpful. I don't really like formulas that much if there's a way to understand it like logically. And for this, I think the best way to understand it is just you're multiplying by the same number over and over, right? We don't need to think about exponents and stuff. I mean, what you're doing is exponents. Exponents are just repeated multiplication. That's exactly what we're doing. But I don't really like thinking of it that way. But if it's easier for you to do that, go ahead and look up the formula and try it. But the thing is that even if you think you have the formula memorized on test day, it's really easy to forget a formula if the formula doesn't make sense. That's just my opinion on formulas. I'm kind of a formula hater. Okay, so the next choice is 6, right? Does 6 work? How do we get from 2 to 6 using multiplication? We multiply by 3. 2 times 3 is 6. Now, this probably isn't going to work, but 6 times 3 is 18. 18 times 3 is definitely not 128. I mean, you can put it in your calculator, you'll get 54. That does not work. So B is not it. Sorry, I'm not sure if you answer this again, but how should we pace ourselves, and do you think it's better to hide the timer? Um, the best way, if you're wanting to like practice the pacing, it's about a minute per question. If you solve each question in about a minute, 45 questions in 45 minutes, that gives you 5 minutes left to review and just make sure that everything's good. Now, technically, the questions at the beginning are easier, so you should be doing the beginning questions a little faster and then the ending questions a little slower. But what I would suggest is even for your practice, just say, okay, I've got 10 practice problems, maybe pull up the official ACT practice problems and just be like, I'm going to set a 10-minute timer and do 10 problems, or 11 minutes if you want to be more realistic, I guess. But just like doing that, even with just 10 problems tonight, just being like 10 minutes to do 10 problems, that'll give you an idea of how fast you have to go. Because, yeah, and if you're taking a paper test, should we bubble as we go or at the end? I've heard people say bubbling at the end is good. I've never done that personally. I feel like that's kind of stressful because I'm in my head, I'm always going to be like, do I have enough time? How much time is left? Do I need to start bubbling now? Do I need to start bubbling? I don't know. So I just bubble as I go. I don't know. That's just the standard thing, I guess. I don't know. If you, whatever, again, it's just whatever's easier for you. There isn't any right or wrong way to do it. I just feel like I would be thinking it would stress me out seeing that I'm not bubbling anything in. And then I'd be like, when am I supposed to bubble it in? Do I go now? Do I go now? And I'll anything that you're thinking about that's not the problem is just going to distract you. So, okay, 8 for our second term, right? Let's see if 8 works. And because I mean 128 you might recognize as like a doubling number if that makes sense. So I have a good feeling about this one, but 2 times 4 is how you get 8, right? To go from 2 to 8, you have to multiply by 4. If you multiply by 4 again, 8 times 4 is 32, and 32 times 4, you could put it in a calculator to confirm, but yes, it is 128. So C is going to be our answer here, 8. You didn't technically need to test the answers that way. You could have just like recognized like even just testing out numbers in your head, like what if I multiplied by 4? That sounds right. And test it out. Whatever works. Honestly, testing out answers is a good way to solve problems, as long as it's not too slow. So that is how I would solve that one. Oh, I didn't answer the part about do you think it's better to hide the timer? And I mean, yeah, I wouldn't look at it too much. Like, it's definitely helpful to like look at occasionally, but you don't want to be like looking at it after every problem. Like just get in that math flow state. Okay. In the given figure, we've got a geometry one. These ones always scare me, when I see the big, like, geometry, blob of geometry, I'm like, geometry. Ah. If you can't tell, I like algebra better. But this one is, it's not bad, but it's not easy. Do you recommend a way to start with an option choice for a test? Like, which is the best pick? If you want, like, you can go from just A to D if you want to, it doesn't matter. But just with problems, like usually there's a couple answers that you can eliminate just because they're so obviously wrong. I mean, if you just like um think about it logically, right? Like you can test out answers that you think are most likely to be correct. It's just totally down to the problem. Like when you're doing the sequence problem, you might be like, okay, 4 is probably not the answer. Like 2, 4, 8, and then 120. It's probably not the answer. So you can start with the one that just like when your first instinct, whatever you think your first instinct is after looking at it, you can test that one first. That's what I would recommend. Okay. So here we've got lines A and B, they're parallel. Who cares? What is the value of X? So X is hiding all the way down here, right? So this is what we're looking for right here. We're looking for an angle measure. Now there's 2 ways to solve this, and honestly, either one works. You can just keep solving for different angles and hoping that it leads you to X. And honestly, there's nothing wrong with that because the only reason they give us these angles is because they're going to help us find X. So that works. Like just keep solving angles until you get to this one. Or you can work backwards. So you can look at the final answer and be like, okay, what is going to directly help me find this? And then, so like for example, there's a rule in geometry which is known as vertical angles. If you have an X, if 2 lines make an X like this, then the two vertical angles, the ones that are vertical of each other, are equal. So you can say, okay, well, if this one's x, then this one is also x. And you go, okay, well, now how do I find this angle? Well, it's part of a triangle, so maybe I need to find this angle and this angle, right? To find the other two angles and then find out what x is. So there's two ways to think about it. So however you want to think about it, let's do it the second way because I've already done it, you know? So we know that this right here is also going to be equal to x. And we need to figure out what the other two angles are of this triangle. Because remember, a triangle adds up to 180 degrees. So if we were to find out what these other two are, then we can figure out what x is. So let's take these one at a time. I'm going to erase as much as possible just to not confuse us. What is this angle right here? And it seems like, well, I don't know how you're supposed to figure out this angle. Like, what is this? Well, honestly, it's kind of cheesable. If you think about it, they don't really give you that much information. This angle looks a whole lot like this angle. It looks pretty much the same. So this one's probably 50 as well. There's not really any calculations for us to do, right? So honestly, you can think of it like that. You can just be like, there's really no other, like, what am I supposed to do? Like, multiply this by 3 and then divide by the square root of, like, there's nothing really for us to do other than just to copy this down. The technical rule, if you want the technicalities, is I don't know if you've seen problems in geometry where it's like two lines, like parallel lines, and then a line going through it, like this. It's called a transversal. And basically, you can have what's called corresponding angles. So you have a set of four angles here and a set of four angles here. And any angles that go together are the same measure. So like the bottom right corner and the bottom right corner, the two bottom right corners are the same angle measure, the same number of degrees. Or the two top left corners are the same number of degrees. And that's actually what we have going on. Here are our two lines, and here's our transversal going through it. We have a bottom right corner and a bottom right corner. So if you want to think of it like that, you can. But honestly, if I was looking at this, I'd just be like, this looks like this angle, 50. And maybe that's not the technical way to do it. But I mean, you got to take shortcuts where you can. Uh, okay. What about this one here? This one's interesting because remember, we also need to figure out what this angle is so that we can find the third angle. But how do we get from here? Because we don't know what this is. Because this is a bottom left and this is a bottom left. So the two bottom lefts are going to be the same angle measure. But what is this one right here? See, we're working backwards from the answer to the question. Any tips for the end of the math section? My last math class was geometry, so I don't know how to do that math yet. I would say just like practice problems are always the best, but if you like have never seen that kind of problem before, I understand. Most of it, um, can you turn up your mic? Honestly, it's turned up pretty much as much as possible. Like if I turned it up anymore, it would start like um I forgot what the term is. Like when it cuts out and like my mic is already going to the red somewhat, but I do agree it's really quiet and I'm really upset about it. I wish it was louder. I always turn it up afterwards in editing for my videos, but for live streams I can't really do that. So I guess you can just turn your volume up, but yeah, sorry about that. Okay. So what is this angle here? Oh, wait, I didn't give the tips on the math section for uh most of the problems, I feel like if your highest point is geometry, you'd already be able to do most of them. It's less about knowing obscure things, and it's more about just logically thinking through math. It's more skill based than it is like knowledge. But there might be some things that you don't know. And so if you want, you can kind of just review a couple things. But go look at like the ACT official practice tests. Go look at the later problems, like 31 through 45, like the later ones, and see if there's anything that you're like, I have no clue what this is, or something that you're like, I don't know how to solve this, and maybe try to look up how to do that. But obviously, because it's the night before the test, it's not like, you have a bunch of time to look up things. But I think you'd be able to do most of them. even with geometry as the highest. And at what point in the math section do you think these questions will come? No idea. I pulled a lot of these from kind of the middle of the test, I think. So, or actually, no, some of these are just from a like an ACT book. Like, I mean, I changed the problems a little bit from the book, but so yeah, I don't know. This seems like a mid-range problem. Like it's got more steps than usual. Oh, the unit circle? Yeah, I mean that does help. There are usually a couple questions like that. Okay, so this little angle right here, right? How do we find this angle? Because remember that this angle is going to help us find this angle, which helps us find this angle, which helps us find this angle. I know it's like 4 steps, but the reason we were able to figure that out and look ahead like a pro chess player or something is because we started from the end. We said we want to find this. Well, to find this, we're going to need to find this. And if we want to find this, we'll need to find this. And if we want to find this, we'll need to find this. So that's working backwards is a good way to think about it. Now, what do we have here? We have a straight line. Yeah, I'm taking too long on this problem, but whatever. We've got a straight line. Like feel free to chat. I like chatting about the ACT. So remember, a straight line is 180 degrees total. That is an important math rule to know. I said it's not that much about knowledge, but this is some knowledge you need to have, right? A straight line is 180. Now this one is 110. So how much is left for this angle? Well, you just do 180 minus 110, right? And that gives you 70 degrees if you were to put that in your calculator. So this angle right here is 70. Now, sleeper on playing Insomniac. Yeah, unfortunately, this was like the earliest I could stream today, but I mean, I figured that, we'd have enough insomniacs in the chat that would be willing to put up with a late stream. I don't want to go to sleep. I mean, sleep is important though. Get good sleep, but also study. But get good sleep. You need to have your brain energized for the test as much as possible. I mean, I know you have to get up early, but Okay. So we already figured out that we wanted to know this angle, right? And we know that this is 70 as well because they're both bottom left corner angles. 70, 70. Okay. Now, based on that, we have remember that we are doing all of this so that we can find this angle. This angle will help us find this angle. They're the same. And to do that, we need to know a triangle rule, which is exactly the same as the straight line. A triangle always has 180 degrees. Very creative. Creative geometry. Do you think we should just go to sleep and review tomorrow morning, or do you think it would be too much to take in tomorrow? Um, I mean, you can like do a couple problems as a warm up if you want to like warm up your brain, but I don't know. I'm not a fan of studying the morning before. I feel like I would just dread that because you're already going to be racking your brain with stuff for like 3 or 4 hours straight. So adding anything to that is like, eh. I mean, yeah. I mean, you can review a little bit tonight if you want, but I mean, sleep is important. If you need to get some sleep, then obviously get some sleep. Sleep is very important. Okay, so we're finding this angle right here. Oh yeah, and especially because it's summer now, so everyone's sleep schedules are probably all like messed up. And now you suddenly have to take a test. I feel bad for you guys. All the July ACT takers, like having to do it on a summer sleep schedule, that stinks. Do you think they made the ACT harder? I'm not sure. I know it's less questions, so it's probably kind of the same. I feel like uh because even if it's harder, that they probably calculate that in. So the average score is always going to kind of stay the same. There isn't really an easier or harder test. And honestly, when they say enhanced ACT, I don't really know what that means. I think it's just what they call the less questions version. Okay, let's finish up this problem and then we can chat. So this angle right here is a missing angle in the triangle, right? We know the other two angles and we know they have to add up to 180. So in total, this is 180, but this angle right here is taking up 50, right? and this one is taking up 70. So we have to subtract those out. And how much is left for our third angle? Well, 180 minus 50 is 130, minus 70 is 60, right? So there's only 60 degrees left for this angle here. I know this is really tiny, I'm sorry, but yeah. So this angle is 60, and that means because they're vertical angles, this one is also 60. So our answer is C. So that problem had a lot of steps, but we were able to solve it because we worked backwards, just thought through it from the end to the start. What is our goal? How do we reach that goal, right? So if anyone has any questions about that, let me know. And we've got a little bit of a word problem with probability in it this time. Should I pull an all-nighter and study? Maybe not an all-nighter. I mean, it's cool that you're studying now, but like, uh, not having good sleep for a test, probably hurts more than studying helps you. So that's just my opinion on it. You'll probably do better if you sleep because then your brain cells will be more energized for the test. Enhanced pain. Yes, that is the ACT for you. I always zone out during the sections. Yeah. How long is this live gonna be? Probably like an hour and a half or so. It's 10 problems, so we're on number 5. And then, we might chat a little bit. Okay. So, oh, and by the way, you can always rewind too. If you miss a question, you can always go back and rewind and try it out and then come back to us to the live people. Thanks for all the helpful videos. No problem. Okay. If you guys haven't tried this problem out, start thinking about it in your head. Even if you don't have pencil or paper around you, just like think about how would you start this problem? That is the hardest part sometimes. How do you even start? Where do you start? That's like the hardest part of doing test problems sometimes. Got to get my hydration break in, like the World Cup. I should be showing commercials right now while I drink water. Okay, so in a certain class, we have 40 people, right? Actually, let's skip to the end. Venn diagram. If you draw a Venn diagram, it might help with this. Let's skip to I'm probably not going to draw one, but it might be helpful. Let's see what it's asking us to find, right? And then we can go back to the problem and see what information it gives us to solve it. So it says, what is the probability? So we're looking for some odds, right? Some chances that a student chosen at random likes both apples and oranges. That is what we're looking for, right? And really all that means is how many people, right? Like, for example, if there were 20 people that liked both, well, 20 out of 40, that's half of the students, so it'd be one half, right? That's really all it's asking. I know probability is kind of scary, but I actually did a poll a little bit ago. I was like, what's the scariest part of the ACT math sections? I think it was like 62% said statistics and probability. So if you're one of those 62%, this problem's for you. It's weird because it's like it's not that hard, but I think the reason it is so hard is because they don't really teach it that much in school. Like they teach all the other ones and then statistics, they don't really touch that much unless you take statistics, which a lot of people don't. So I understand why it's a pain to have to try to do probability problems. Okay, so we have 40 people total, right? Who like apples, oranges, or both. So all that means is we're not going to have any total fruit haters, right? Everyone's going to like at least one fruit. So we have exactly 25 students. Actually, let's draw a Venn diagram. All right, let's do it. Let's do it. I think it'll be helpful. So we have 25 apple enjoyers, and we have 30 orange enjoyers. Now, already, you should be like, wait a minute, that doesn't make sense. We have 40 people, 25 like apples, and 30 like oranges. You're like, huh? How does that work? Well, that's because some of them like both. That is the worst Venn diagram of all time. I'm sorry to anyone who is a Venn diagram enthusiast. Um, but yeah, so what is our goal, right? We're trying to find how many like both. Well, there's multiple ways to think about this problem. I did look, there's an ACT approved way of solving it, but it's kind of lame. So one way you can think of it is what is going to make this balance with 40 people, right? Like, for example, let's say that one student liked both. Well, you would take one away from the apples and one away from the oranges, and you'd put one in the middle, right? And what that does is it removes one of the extra students. So if you want to think of it like this, you can just be like, hey, how many students extra do we have? How many do we need to move to the middle to have 40 people total? Well, 25 plus 30 is 55. And so what do we need to do to get that to 40? Well, we just need to bring this down by 15. And if you didn't know that, you could do 55 minus 40. So 15 students, that's one way to get 15 students. The ACT approved way is to think of this as the opposite of the situation. So you can ask yourself how many don't like apples and how many don't like oranges. And then anybody who's not in either of those must like both. So we've got our apple haters, right? So our apple haters, how many apple haters do we have? Well, we have 40 people and 25 like apples. So 40 minus 25 is 15. So we have 15 apple haters, right? Now, how many orange haters do we have? Well, we have 40 people total. 30 of them like oranges. So how many don't like oranges? 10 of them. 10 of them don't like oranges. So we have 15 apple haters and 10 orange haters. But we're trying to find how many people like both. So that means that they're not either of these. They don't hate any fruits. They love apples and oranges. So how many people are left? Well, we have 40 people total, minus the 15 apple haters, minus the 10 orange haters. And that's going to leave us with 15 students left that like both. So that is the ACT approved way of solving it. But that's much longer than just being like, okay, we have 15 more students than 40. So two ways to think about it. Now, you might be asking yourself, what does this have to do with the problem? Because there's no 15 here, right? They're all fractions. Well, that's what we're going to do next, right? Because we have 15 people who like both. But it's what's the probability if we chose a student at random? And the way we do that is with a fraction. So we have all of our possibilities at the top of our fraction, our possible successes. We have 15 different people that we can choose to be successful. Out of, and the bottom of the fraction is always your total amount of possibilities. So like if you're trying to pull a red marble out of a jar, right? If there's 8 marbles in the jar and there's 3 red ones, then it would be 3/8. The top is our possible successes, and the bottom is however many different ones we can choose from. And in this case, we have 40 different people we can choose from. So out of the 40 people, 15 will be a success, will be a person that we choose that likes both. Now, that's still not one of the options, and that's because with fractions, you can always simplify, right? Now, remember when simplifying fractions, you have to divide something from the top and the bottom. Now, I'm noticing that these are both able to be divided by 5. The way you can tell that is because it ends in a 5 or a 0. If it ends in a 5 or a 0, that means it's divisible by 5. And if you didn't know that, you can just plug it into your calculator, try dividing them by 5 and see if they both come out to whole numbers. So 15 divided by 5 is 3, and 40 divided by 5 is 8. And at last, we have one of our options, which is option B, 3/8. So that's the answer. And then, whenever you get an answer, always do a sanity check. Does it make sense for us to have a 3/8 chance, a 3 out of 8 chance of picking someone that likes both? It's a little bit less than half. I think that makes sense. Okay. Problem number 5 done. We are halfway through this review, everyone. I mean, the problems get a little bit harder, but it's okay. We're gonna make it through. Okay. This one is another one of those raw geometry or raw algebra ones. What is the sum of the two solutions of the equation x squared minus 7x minus 30 equals 0? Now, again, there's the ACT approved way, and then there's kind of a cheesy way to solve this one. So see if you can think about how to figure out both of those ways, maybe. I mean, you don't have to know how to cheese problems. It's not that common that you're actually able to cheese ACT problems. So just knowing how to solve this normally is good enough, especially if you can do it fast. But there is kind of a shortcut to solving this problem. Okay, let's do it the ACT approved way first. So what kind of the Desmo? Okay, I didn't even think about, okay, there's two shortcuts to this problem. There's a cheesy, cheaty way to use it, to do it, and then there's also Desmos. Yeah, Desmos you can use to solve equations like this. You can just plug it in, and then what it's going to do is, so if you, or your graphing calculator, if you're taking the paper ACT, it's going to give you something that looks like this, right? It's a parabola because it's a quadratic equation. All you have to do is look at where it crosses the horizontal line, the x-axis. And wherever it does that, like this is in the middle, so this is going to be 0, and then let's pretend that this is like 4, right? Then your answers are 0 and 4, right? So that's one way to solve equations like this on Desmos. One of the few cases where Desmos is actually really helpful. But let's say you didn't know how to do that. Well, what is this? It's a quadratic equation, right? Now, I can't imagine it wants us to use the quadratic formula. I always like to see if factoring works first. Now, how do you factor? Well, you have to find two numbers that, well, first of all, remember that the goal of factoring is to create two sets of parentheses with an x in each one. It's going to be x plus a number or x minus a number in each one. And it's still going to equal 0, right? So how do we know what to put in the parentheses? Well, we have to find two numbers that add up to -7, because that's the number in front of x, and multiply to -30, because that's the number by itself. It's always the number next to x you add to, the number by itself you multiply to. Now, minus signs always stay, remember, they're part of the numbers. So let's go ahead, and I always like to start with multiplication. So what are numbers that multiply to -30? Well, there's the obvious one of 1 times -30. Anything times 1 is itself, right? Now, notice how I'm always going to put the minus sign on the bigger number, and that's because we're adding to a negative number. So if we were adding to a positive number, I would start putting the minus signs on the smaller number, because that's how you're going to, like 30 minus 1, that's going to give you a positive number. But because we're adding to a negative number, we're always going to put the minus sign on the larger number. So 1 times -30 is -30. Let's see if that adds up to -7. It doesn't. It doesn't. It doesn't. This will give you -29, and you can put that in your calculator if you want, but that's definitely not correct. That is not what we're looking for, right? So that is out of here. There's also 2 times. Oops. There's also 2 times 15. 2 times 15 is 30. We're going to put the minus sign on the larger number because we're adding to a negative number. And this is going to get us closer to -7, but not quite. 2 minus 15, if you put that in your calculator, you'll get -13. And we're looking for -7, so that's wrong. What about 3 times 10? 3 times 10 is 30. We put the minus sign on the larger number, and you can put this in your calculator, or you can just think of it like money. You gained $3 and then lost 10, so you're down $7. And that is what we're looking for, -7. So there you go. That means that the numbers that are going to go in the parentheses are 3 and -10. So you just have to insert those in. +3, -10. And there you go. Now, we can't go ahead and solve these yet because these are not our two solutions. Remember that this is just like the problem we did earlier where you're solving for a letter. We're trying to get x by itself. We are trying to figure out what x is equal to. And the way that we do that with factoring, the whole reason we did this is because this is multiplication. Now, how do you get 0 for multiplication? Well, it's by multiplying by 0. Whenever you multiply by 0, you always get 0. And these are two numbers being multiplied. So if x plus 3 is 0, then the entire thing is 0. It literally does not matter what x minus 10 is. It's going to be equal to 0. Or if x minus 10 is equal to 0, the whole thing is 0. It does not matter what x plus 3 is, right? It could be 1 million times 0, still 0. So How do we do this then? Well, either one can be 0. So there are two different ways for this to be true. Either x plus 3 is 0, or x minus 10 is 0. If either of these are true, the whole thing is 0. And now we can just solve each of these equations to get our solutions. So let's get x by itself. There's a plus 3 in the way, so we can do the opposite of plus 3, which is minus 3 on both sides. So these cancel out. On the left, we just have the letter x. And on the right, we have 0 minus 3. The 0 is not doing anything, so it's just minus 3. That is one of our solutions. I am taking the ACT for the first time, so do you have any tips? Um, just, I mean, obviously looking and reviewing practice problems is the best way to study. That's why we're doing this here. So good job on that. And, just take it slow. Like, I mean, obviously it's a timed test, but the less that you stress and stuff, the better. So yeah, I mean, don't worry too much about it. Just go into it doing your best. It's not like a test in school where you have to study these specific things, and if you're missing any one of these concepts, you're gonna fail. It's like it's one of those tests where you have no clue what's gonna be on it, and it's just gonna test your math skill in general. So studying is important, but just do your best. Use whatever skills you already have to the best of your ability, and just, get good sleep and go into it confident. That's what I would say. And then, yeah, okay. So then on this one on the right, let's go ahead and get x by itself, right? We have a minus 10 in the way. So let's do the opposite of minus, which is plus. Let's do plus 10 on both sides. So these cancel out. On the left, we just have the letter x. And on the right, we have 0 plus 10, which is 10. So 10 is the other answer. Now, that was a long problem, but with factoring, it's one of those things that you do it the same way every time. So if you just practice these problems, maybe do like one more like this, try to do it on your own. Uh, the process is always the same, so you'll be able to do it really fast. Now, what is it asking us? Remember, always look at what the question's asking. What is the sum of the two solutions? The only reason it's kind of dumb, you would think that the question would just say, what are the two solutions? I think the reason they do this is because they don't want you to cheat and just test out each answer to see if it works. They want to kind of like mask what the answers could be so that you have to work it out yourself. So it's just asking for the sum. Add these together. Minus 3 plus 10. That's the same as 10 minus 3, which is 7. So answer 7. So that's how you factor. Now, before we move on, I was teasing at the beginning that there's a cheesy way to solve this. So you still have to know how to factor, right? You have to know how factoring works, but you don't have to actually factor. So notice how it says when you're picking out your two numbers, you always have to add to the number next to x. And it's asking for the sum of the two solutions. So, I mean, -7, you're adding is -7, so the two numbers are going to add to -7. But the answer we got is +7. Well, that's because the numbers that are in the parentheses, the signs always get switched. And by the way, this is only just assuming that it's x squared and not like 3x squared, right? That complicates things if you have a number in front. But when it's just x squared, well, whatever numbers you put in parentheses, they just end up getting flip-flopped. Like if it's positive, it becomes a negative. It's a negative, it becomes positive. So you can just, if you already know that, if you have that knowledge going into the test, if you already know how factoring works, you can just be like, okay, they're going to add a -7, and then the sign is going to switch. So they need to add to +7. And you don't even have to actually solve the problem. But again, you have to understand factoring. Like the cheesy ways to get out of doing problems aren't like a substitute for math. Like really the only way you can cheese problems on the ACT is by already knowing how to do it and then going one step further to know a shortcut for how to do it. So in case you guys already knew how factoring works, this is a good just shortcut to use, especially when you only have about a minute to solve each problem on the ACT. Now, I don't know if this type of problem scares anybody, but this is a conversion, like unit conversions. I feel like this is the kind of problem that would be uh, a little worrisome on a test, but you just take it one step at a time. So for this one, we have a guy named Mr. Walker, fittingly, and he walks, right? So Mr. Walker walked 4,800 steps today, and he covers a distance of 2.75 feet per step. Okay, so that's not very helpful for us, right? Let's not try to take all that information in already. We learned this in chemistry. Yeah, that's honestly the first thing I thought of too. It's like we learned this in chemistry. It was called stoichiometry. Yeah, I remember that. I was like, why does it have such a funny name? It's just, but yeah. So if you know the ways of stoichiometry and you want to do it the like bridge method or like the with all the units and like the fractions, you can do it that way. And if you understand that, then that's going to be that's really good. We're not going to do it exactly like that for this. I mean, it's basically the same thing. Just different ways to write it. Let's look at what it's asking us, right? It wants us to find to the nearest zero point 0.1 miles, so in miles, how far did he walk? So we're trying to find the miles that he walked. And you might be like, I don't get it because it does not give us miles anywhere else. I mean, it says 1 mile is this many feet. It gives this to us in feet and in numbers of steps. So we're going to have to do some conversions, right? So if we can't, we're trying to figure out how far he walked. That is our goal. How far did he walk? Now, if we can't figure that out in miles, let's just figure it out in some way. What is some unit of measure we can use for how far he walked? Well, he walked 4,800 steps. That's not very helpful. I feel like if we're trying to get to miles, feet is going to be more useful than steps. So let's try to turn this into feet. I'm taking the September ACT, and it's the only shot I have at a 34 plus. That is a good goal. What question types have been showing up more on recent ACTs when study? I'm not sure because I haven't really looked at the actual recent ACTs. I don't even know if those are available. Like, are the ACTs publicly available? I'm not sure. Uh, I'm not really sure what's been on recent ACTs, but I feel like the official ACT practice tests are probably the best indication of what you can see. And you can all also look up like because there's 5 different types of ACT problems, right? I did actually see one time I think I mentioned in a video one time, there was this like Reddit post I saw that they did a statistical analysis of like the 10 most recent ACTs at the time. I think this was pretty recent. And they came up with like 75 different math topics that were on the ACT, and they were all grouped based on what percentage rate they're on the test. Like there were 15 that were in guaranteed to happen. Then there were 15 and 80% chance to happen. Then there were like 20 and 50% chance to happen. So if that's something that seems like it'll be really useful for you, then the video is called the 5 ACT strategies that actually work or something like that. And then I think in the description of that, there's a link to that post if you think that'll be helpful to you. Man, I really want to watch the World Cup matches for this ACT. Yeah, having to study, especially over the summer, stinks. But you'll get through it. It's tomorrow, and then after tomorrow, you can go back to watching the World Cup. And then is there much quartic polynomial factoring on the ACT? Uh, oh, like if you just mean like the quadratic, um, I don't know. I mean, it's kind of an oddly specific topic. I feel like it's a common one, but it's not like there's going to be more than 1 or 2 problems about it. It's not like there's going to be 5 different factoring problems. So if it seems overwhelming and you don't get it, there's probably not going to be more than one. I can't imagine. So don't worry about it. Uh, yeah, it's not like you're going to see like 5 of the same type of problem on the test, right? It tries to test a wide variety of topics. So I wouldn't get like hung up over a specific topic. Oh yeah, who's everyone rooting for the World Cup, by the way? I used to be into watching sports, and then I don't know, I kind of just stopped being interested. But I still like occasionally look up like how the USA is doing. Well, they're out now, so like what's the point? But And then let's say I get a score that I'm not happy with and I want to improve. What is the best way to improve besides just practice questions or practice tests? Um, well, I mean, practice tests I feel like are the best way to do it. Um, but besides that, I mean, I would say like watch other people do them to kind of get a sense of what strategies they use. And then you can do them yourself. Honestly, that's the best way to do it. I mean, I wouldn't like, because I mean, other ways to practice might help, but I know that solving practice problems is kind of feels like a lot of work and it feels probably the most boring method, but it's the best way, honestly. I can't really think of anything else that would be better. All the the World Cup hype. I've been seeing a lot of things about it. I mean, I don't really know who the players are, honestly. I'm kind of unknowledgeable, but yeah, I'll like look up and see who won, and I'll be like, oh, great, they won. Like, were they good? I don't know. Okay, so we have 4,800 steps. Remember, our goal is to turn the number of steps into miles, but we don't know how many steps are in a mile. That's not given to us. We do have feet. So what if we convert the steps to feet and then convert the feet to miles? Feet seem like they're closer to miles than steps, right? Steps make no sense. But feet can turn directly into miles. And we know that because we have a hint here. 1 mile is 5,280 feet. So let's go ahead and do this. It says that we have 2.75 feet per step. So every time he takes one step, he goes 2.75 feet. So how do we do this? Well, we just multiply by 2.75. 4,800 times 2.75. That is going to give us 13,200 feet, right? Now, what is the last thing for us to do here? Well, we need to turn this into miles, correct? And we know that 1 mile is 5,280 feet. Now, in this case, we're going to divide, and you can just kind of like think through that logically and be like, well, we're trying to make this number smaller, right? If we're going to miles, this is going to become smaller. So we're going to divide by 5,280. And if we do that in our calculator, we get exactly 2.5. 2.5 miles, that is option B. And as always, do a sanity check. Does it make sense? He walked 4,800 steps. That's a pretty good walk. Uh, 2.5 miles. That seems like a pretty average walk to me. I mean, I mean, it's a lot more than average for me because I like don't exercise. But maybe for Mr. Walker, that's a pretty good walk. The chem thingy really helped with this one. That's good. Yeah, if you've already done these kinds of problems in chem, then I could imagine this helping a lot. And first ACT tomorrow. Let's go. Testing, math testing, so fun. Uh, Getting straight 33s on all my practice tests. Wow, and you haven't even taken the test yet. That's really good. Tips. I don't know. You're already doing great. And especially if it's your first one. So if you're planning on taking it more often, then for your first one, just get used to it. Get used to what the test is like. If you're not planning on taking it again, still, I nothing different. Just do your best. If you're wanting to improve a little bit, these next few problems actually are going to be slightly harder problems. So I would say look at some harder example problems. Go to the official ACT ones. Go ahead and skip to the bottom. Look at what the hardest problems look like. See if you can solve them. And if you don't know how, then like see the explanation for it. But if you're already getting 33s, and yeah, just go into the test, do your best, and uh, yeah, I mean, you're doing great already. We've got three more problems for this one. And this one, we've got fractions. I know this one kind of looks a little bit scary to start, but, uh, you know, the ones that look the scariest sometimes are the ones that you can just solve in 2 seconds. And then the ones that you think you'll solve in 2 seconds end up taking the longest. That's just happens sometimes. Okay. So the first thing to know is that sometimes, so you know how like commercials and things, they'll sometimes have fine print at the bottom, like they'll have the big words and then they'll have all the little tiny text. It's like the guy talks really fast and blah blah blah, right? You're like, what does that have to do with the ACT? Well, in this case, when it says for all non-zero values of b, when you see this, I want you to just think fine print, right? Why is it telling us this? For all non-zero values. Well, basically, it's just saying because if b was zero, because this is all non-zero. So if b was zero, we'd be dividing by zero, and that's illegal in math. You are not allowed to divide by zero. So the only reason they're putting this here is because they're trying to get rid of the technicality. They don't want people to be showing up being like, well, no, because if b was equal to zero, then it's not true, you know? So that's why that's there. But if you want, you can just ignore this. Pretend this is not even here. So what is the question asking? Which of the following expressions is equivalent to this? 3 over b plus 4 over b squared. Now you'll notice that, because remember, it's like, where do we even start with the problem? That's the first thing you want to think about. Where do we start? Well, the problem has two different fractions that are being added together. Now, it looks like because we have the letter b, we're not going to be able to simplify the fraction or like divide it, but all of our answer choices are just one fraction. We have to go from two fractions to one fraction. So what does that mean? We need to add them together. That's why we have a plus. So 3 over b plus 4 over b squared. Okay, how do we add fractions? I know it's a little bit different with letters, but it's the same thing. Yes, Desmos is on the computer ACT. Yep. Uh, well, how do we add fractions? Even if you were just like, channeling back your elementary school days where you learned how to do this, obviously we weren't doing it with letters, but the same rule applies. The bottom of the fraction has to be the same for both fractions. That's how you add them together. Like 2 over 5 plus 1 over 5. You can only add them together because the bottoms are both 5, 3 over 5. Now, the bottom of the fractions are not the same right now. So how do we fix that? Now, when I first saw this problem, I was about to make a mistake. I was like, well, why don't we just square the top and bottom of the fraction and then we'll have b squared? But then I had to, have a wake up call to myself. And I realized, wait a minute, you're not allowed to do that for fractions, right? Fractions are not like equations where you can do whatever you want to both sides as long as you do it to both, right? Fractions are not the same way. Uh, the only reason that we can do that, 36 viewers right now, is that a sign? Yes, it is a sign. You're all going to get a 36 now. Only the ones who are watching right now, though. Like anyone who comes later, they didn't witness the 36, so they don't get a 36. So if one more person joins, then you all get a 37. I don't know how that works, but just trust me, all right? You're all going to get a 37 on the ACT if one more person joins. It's going to be a world record. So the reason I thought of that is because what a lot of people do for fractions is you can multiply the top and the bottom by a number. Like you can multiply by 2 over 2. And you can only do this with multiplication. You can't add 2 to the top and bottom or whatever. Why is that? That's because what is 2 over 2? Any fraction that's the same number top and bottom is just equal to 1. And if you multiply something by 1, what does that do? Absolutely nothing, right? If you have the number 8, you multiply it by 1, it's still 8. So the only reason we're able to do this is because we're multiplying by 1. That's the key thing. And this is what people usually do to get a denominator to be what they want it to be. Now, that seems kind of weird because we have a b squared. How do we get from b to b squared by multiplying? Well, what does squared mean? What is the definition of squaring? Squaring is multiplying something by itself. So b squared is the same thing as b times b. Okay, well, how do we go from b to b times b? We multiply by b, right? But we have to do it to the top and bottom, right? So let's multiply this fraction by b over b, right? If we multiply by b over b is the same as 1, so we can do this. Let's multiply the top and the bottom by b. So on the left, we're now going to have b squared. And on the top, we have b times 3. Now, we can't multiply a letter and a number, so it's just going to have to stay the same as b times 3. Normally, we put the number first, so we'll do 3 times b. And now suddenly we have two fractions that we can add together. They both have b squared at the bottom, and now all you have to do is keep the bottom the same and add the tops. 3b plus 4. Now remember, you can't add those. These are not like terms, so don't be fooled by these ones that have 7 at the top, right? We're not allowed to add these together because they're not like terms. They have to, one is a b and one doesn't. So it has to stay as 3b plus 4. And you'll see that that is actually answer choice A. Answer choice A is 3b plus 4 over b squared. Low-key forgot Desmos on digital ACT. I signed up for paper. Yeah, I mean, if you're taking paper ACT and if you have a graphing calculator, I would suggest bringing it because it does basically the same thing as Desmos. I mean, it's a little bit less convenient than Desmos, but it does the same thing. If you don't have a graphing calculator, I would say don't worry about it because honestly, it can be more of a distraction just because it's not that helpful. Like it's not like it's life changing to have a graphing calculator. It's not like a hack. It might help with one or two problems and then it won't be much use anyway. So that's why I always suggest to just take a few minutes to learn it. If you do have access to Desmos or a graphing calculator, just because it could be helpful, but don't try to rely on it for the whole test because it's not as helpful as the hype makes it seem. And yeah, graphing calculators, honestly, like physical ones, they're pretty annoying and they take a while. But when I took the SAT, I don't remember ever using the graphing part of my graphing calculator, like at all. And the ACT really doesn't have that many graphing problems. I was surprised by how little graphing there really is on the ACT. Like, honestly. I mean, I say that, and then there's going to be like 20 graphing problems. But from my experience looking at practice problems, I don't think there's that much graphing. Are these questions the same difficulty as the ACT? They should be. They're not the exact same questions, but like they're inspired by the questions from I actually just got the official ACT math guide book to help me make practice problems. So they're very similar to the types of problem. Not like saying that this is guaranteed to be on the test, but they're probably about the same difficulty. And also the difficulty on the test is all over the place. It starts out easier and gets harder as it goes. So that's also what I'm trying to do with this live stream, starting with easier problems, going up to harder problems. But ACT difficulty is just all over the place. So this question is so relatable. This is like they're the most useful math problem you'll ever need to do in life. You're like, how is math useful to my life? Calculating your math grade. This is how learning math is useful to your life is calculating what you need to get a good math grade. Other than that, I don't know how much it'll help you. But for this scenario, how many problems you plan on doing? We've got two more after this, or two more including this. We have this one, and then we have one more geometry problem at the end. Last live stream I did some weird, goofy, like kind of deep geometry problem at the end, and I've tried to do the same for this one. Maybe you guys are gonna be like, bro, that's so easy. But I tried to pick a really weird one for the last one. So you'll just have to stay tuned. Don't click away. So I should probably spend more time on the difficult questions and answer the easier questions faster. Yes. So I suggest doing one problem per minute in your practice, like just to practice the pacing. But in reality, your easier problems should be a little less than a minute, and your harder problems at the end should be a little more than a minute. So yeah. Should I start last on the math section? Probably not, because you want to make sure you pick up the easy points. You don't want to get caught up in hard problems. And also, honestly, just psychologically, if you do the easy ones first, you'll get more right, and that will motivate you to go on to the harder problems. So, honestly, I think it would be better to start with to just go from start to finish. But don't get too caught up on a problem. Like if you have been staring at it for a minute or two and you don't know how to do it, just go ahead and skip to the next one, go back to it later. Even though some of them are harder, I believe they're still all worth the same amount of points. So you want to pick up the easy points first. I'm so scared because I keep getting 16 on math. I mean, 16's not bad. But just the fact that you're here doing practice problems, this is how you get better. So yeah, just keep practicing, and like every time you do a practice problem, you're taking away one possible thing that you might not know how to do. You're like, what if I come across problems I don't know how to do? Well, every practice example problem that you look at takes away one of those possibilities. Because now, if you see this on the test, it'll seem familiar to you because you already saw it from watching videos. So there you go. I only had like a week to study, and my practice scores have gone up like 7 points or something. Whoa, nice one. Thank you. I appreciate it. I mean, obviously, like when you guys like watch the videos, like it's mostly the work that you're putting in, right? Like it's not just like a YouTube video you sit and casually watch and then suddenly get a bunch of points, right? Like the fact that you guys are watching this, it takes brain power to watch these, Like you've gotta think about the problems. You've gotta like, you're putting in the work. So really it's mostly your guys' effort right now. I'm just here blabbing about how to do math, and then, you know, uh you guys are the ones that are putting in the brain power. So good job everyone who's watching this. Am I going to be live tomorrow after the ACT? No, probably not. I might just try to do them like the night before, just for these kinds of scenarios. Should I do the last 5 questions first? Probably not, because those might take the longest. So yeah. All right. I'm gonna try to get these last two problems done because I know you guys need sleep. Especially some of you on like the East Coast and stuff. I think it's past 11 on the East Coast. So yeah. All right. Let's see. Jonathan's math grade. I mean, his name is Jonathan, guys. This is very important. Make sure you know his name. And okay, let's skip to the end. What is the lowest score that Jonathan can get on the final to receive a course grade overall of at least 85? So that's what it's looking for, right? He's taken all his tests and he's going to take this final. And he's like, what do I need to get on this final to have an 85 in the class? Now that we know that, let's go ahead and look at the information. Apparently, his entire grade is based on 2 quizzes and a final exam. I feel bad for Jonathan. If I was Jonathan, yikes. I don't know how much I like this math class, but whatever. So each of the 2 quizzes is worth 20% of his grade. So if you want, let's just write this out. So quiz number 1 is 20%. Quiz number 2 is 20%. And then it says his final exam is worth 60%. Okay. Jonathan's quiz scores were 76 and 82. Let's take a second before we solve the problem to think of this through a little bit. He has a 76 and an 82. He wants an 85, right? So already we can eliminate some answers. And like, let's say you're running out of time and you don't know what to do, or let's say you don't know how to solve this. You can like speed run this problem or at least bring it down to a 50-50, right? Let's look at A, 80. Can he get an 80 on the final? Well, if all of his scores are less than 85, he's not getting an 85. His hopes are crushed. So A is gone already. What if he gets an 85 on the final? Well, he wants to get an 85 total. He got an 85 exactly on the final, but then all the others were less than that. So his score is going to be less than 85. So it's not B. So already we've eliminated 2. Now let's say you have 10 seconds left and you're like stressing out. You're like, I don't know how to solve this. Well, now you've narrowed it down to C or D, right? 50-50. So I just wanted to bring that up because, I'm not really a fan of guessing strategies per se, but I think that's a pretty useful skill to have, is just think through the answers logically. Now we can actually solve the problem correctly. Do you have any advice for parabolas? That's one of the few cases where Desmos is actually pretty useful. So a few questions ago, I did a quadratic equation. It was a factoring problem. If you want to, like that's probably the most common quadratic problem you're going to see for parabolas, honestly. Oh, and also know how transformations work. Like if I have a video on it, or if you want to watch someone else's, just call like transformations of functions, probably. Just how does a graph move up? How does a graph move down, left and right? But even that, graphing is not that common on the ACT, at least in my experience. Don't super take my word for it, but so I feel like parabolas are honestly not super common on the ACT. Okay, so how do we solve this, right? The way we're going to do this, if you want to know the fancy math term, it's called a weighted average. This is the second hydration break, by the way, the second half. Okay, I use the weighted average formula, which proved to be useful for this particular question. If you know the formula, then that will be pretty useful. We're basically going to be using it. Can you go over complicated probability statistics questions if possible? Yeah, unfortunately, like on my like finals review live streams, I used to just like take random questions, but we would have to like I've already prepared these questions, so I can't really do all like a whole extra question, unfortunately. But there aren't really too many really complicated probability problems. You just want to know the basic rules, like two things happening at once, you multiply them together, and I mean, honestly, that's probably the big one. But other than that, there's not really any complicated probability. There was like one problem I did on a live stream one time that was like it was a really long word problem that like wasn't that bad. You had to break down what it was saying, and it was probability. So that's what I have to say about probability. It's not too bad on the ACT. You just have to know how it works. Okay, so how do we calculate his quiz grade? Well, what you could do is like, let's say, for example, let's say he got an 87, right? The way you can do it is you can just multiply all of the amounts by the percentages and then see what it gives you. So let's do that on a calculator, actually. I think that's what we can do. 76 times, and now 20%. If you don't know how to put a percent in your calculator, remember 20% is the same as 0.20 or 0.2. That gives us 15.2. Let's do the same with 82. 82 times 0.2 is 16.4. Now, what is this score in total? Well, 15.2 plus 16.4 is 31.6. So in total, right now, he has 31.6 points. He needs to get to an 85. How much more does he need? Well, you can do 85 minus 31.6. He needs 53.4. And, if you're like a math wizard and you want to take shortcuts, you can honestly just divide that by 0.6 and you'll get the answer. But, let's take this a little bit more one step at a time. Yeah, that's the fastest way to do it. But, if you want, because we've already narrowed it down to two answers, you can just test this out. What is 87 times 60% or 0.6? 87 times 0.6 is 52.2. And now let's add these up and see if he gets an 85 in the class. 15.2 plus 16.4 plus 52.2 is an 83.8. Yikes. Too short of an 85, but really close. And I mean, that's a good sign that we're really close because the answer is probably going to be 89. That's just a little bit more, should get us to 85. Are you multiplying with the decimal forms? Yes. I mean, technically, because I'm using my, just an iPhone calculator, and it does have a percent button. So if your calculator has a percent button, then you can do that. But this is pretty important to know. Remember that 20% is the same as 0.20 or 0.2 because the zeros at the end don't do anything. 0.2, 0.6 for 60%. That's what I'm doing personally, but it's whatever you find easiest. Now, 89 times 0.6 is 53.4 for his final out of 60 possible. And if we add these together, we should hopefully get 85. And if we don't, then we did something wrong. We scream and run around in circles. Okay, it's 85. We're good. So there we go. We got an 85. And the answer here is D. And the only reason I felt like it made sense to just test out each answer is because we only had two, right? We were able to eliminate two of them at the beginning. So we only had to test two of them. Oh, yes. You can also do it as an algebra problem. If that, remember, there are almost always like more than one way to solve the problem. So if you think it's familiar to you to solve an algebra problem, by all means, do it if that's what's easiest. You can do zero point 0.2 times quiz 1 plus zero point 0.2 times quiz 2 plus zero point 0.6 times the final equals 85. It's basically the same thing as what we just did, but as an algebra problem. And replace Q1 and Q2 with the quiz grades 76 and 82, and then solve for F. If that is what makes the most sense to you, then do it that way. Do whatever, like, because you don't have much time to think about what's the most efficient way to do this, right? Like, just do whatever is instinctual to you. Whatever the first ways you think of to do it, just do it that way, right? Okay. I was teasing a geometry problem earlier, so it's time to do it. You're like, what is this? Now, occasionally, just a question is, do colleges care if you take the SAT, if you got a good score on the ACT? Probably not. I mean, honestly, I feel like now sometimes the SAT, ACT scores don't even matter at all, for some colleges at least. I know there are still some that want it. I feel like usually it's just an alternative, right? SAT and ACT, they're just like fighting it out to be the ultimate test that tests your knowledge, right? But in reality, they're basically the same thing. So if you got a good ACT score, then that indicates you'd also get a good SAT score. Like I can't imagine someone being like, I got a 36 on the ACT and then I got a 400 on the SAT. Now, like that usually doesn't happen. Like they test basically the same thing. So if you have a good ACT score, I would guess that the average college would say, that's good, then I'm not going to like beg you for an SAT score. Okay, final question of the live stream. It says, Lucy wraps a string around 4 cans. Why is she doing this? That's not the question. So I don't know. Each can has a 2-inch radius. What is the length to the nearest inch of the shortest string that will go around the cans without overlap? Now, we don't really have to think about shortest string too much because it's already in the picture, right? We can see that there is a string being wrapped around these cans, right? There's the string. So that's probably the shortest string. Yeah, I can't imagine this being any shorter. This is like as tight as it goes. Now we have to find the length of this string that's going around the cans. And if you want, you can like, because these, whenever you see the numbers are, they're pretty far apart, right? Like 8 is very different from 29. So maybe you could start eliminating answers if you want. Like for example, if this right here is 2, then this whole thing is probably more than 8, right? It looks longer than 8, so it's probably not A. So if you had no idea how to do this, at least like see if there are any answers that are obviously wrong. Like it's probably not 8. Looks more than 8. I think technically they say it's not to scale, but it usually is. Would you recommend taking the ACT and SAT again if I want to go to a test optional college? Got a 17 on the ACT and 1030 on the SAT. Not bad, yeah. I would say, yeah, I mean, test optional. I mean, I don't know. I'm not the expert on college admissions. Like I didn't I'm not going to like a fancy college or anything. But I would say that I feel like it's never a bad thing to have test scores. The worst that happens is that, you lose your Saturday to having to take a test. Like that's the worst that can happen. The best thing that can happen is you get into the college you want to, right? So I think the reward is much higher than the risk. YouTube is telling me this might be a good time to insert ads. No, it is not. It is not a good time to insert ads. It is not. NC State is test optional. Yeah, I mean, if it's test optional, I mean, you don't have to take it. But I would say, I mean, if you want to go for it, maybe study a little bit and go for it. I don't think you even have to report your scores. If, like, for some reason you don't like your scores, you don't have to give them to them, I don't think. Um, but, oh, that is true. Yeah. If, like, it's all about standing out, right? Like applying to a college, you want to stand out as much as possible. It's this person saying, if most people don't do it, then if you give your score, you're automatically standing out. That is a great point. I agree with that. That makes a lot of sense to me. I mean, I'm not the expert on this, but that makes a lot of sense. They're going to be like, whoa, this guy actually took the SAT or ACT, got a good score, and sent it in. When most people don't do that, like immediately that is like that is plus 5 points for Gryffindor. Like, I don't know. So that's plus 5 points on your application. I definitely know what I'm saying. Okay, let's do this problem, right? So what is the length of the string? Now, first of all, what's the math term? What's the geometry term for the length around a shape? Well, that term is perimeter. I have a 4.25 GPA. Wow, nice. So I think you took some honors classes and stuff, got some A's. That's awesome. So horrible tester. Yeah, I mean, taking a test is definitely a skill that like needs to be developed, even if it's like the material. Just being able to do it fast is another skill, but it's definitely something you can practice. This thing telling me to start ads is not going away. It's really annoying. I'm so cooked tomorrow. No, you're not. We're not cooked. You will cook. And yeah, good luck on the ACT. The fact that you're here again means that you're motivated, and just watching people do problems or doing them yourself is going to help you your score. Okay, so remember the fancy term is perimeter. That is the length around a shape. Now, now you might be like, well, what's the formula for the perimeter of a squircle, if that's what you want to call it? It's like a square circle. What's the perimeter of a squircle? Well, I don't know. That's, there's not really a formula for that, right? So in these cases, you want to break it down into components that you can solve. You might not know how to find the perimeter of a squircle, but we do know how to find the perimeter of a circle. Well, that's called circumference. Technically, it's not perimeter. It's with a circle. So let's break this down, right? Uh, we know how to find lengths of straight lines, right? I see we have a straight line here. We have a straight line here. We've got a straight line here. And we have a straight line here. So then those are all the same length, it looks like, right? So if we just found the lengths of those, we've already done that part. And now what's left? Well, all that's left is these things, these little arcs. And you might notice that these are basically just portions of circles. So we have a quarter of a circle here. We have a quarter of a circle here. We have a quarter circle here and a quarter circle here. So what does that make? We have 4 quarters of circles. That makes a full circle. So all we have is we turn this weird squircle into 4 straight lines plus 1 full circle. So if we find the length of the straight lines and whatever the circumference of the circle is, then that's the perimeter. That's the length of the string. Just doing all this prep just to end up in an RB structure. Yeah, I mean, the real challenge is job finding. I'm sorry, guys, I said the job word, but finding employment is definitely, a challenge as well. You're really nice for doing this because not a lot of people will take time out of their day to teach us about the ACT. Yeah, no problem. I enjoy doing this, just doing these streams and chatting. Uh, I estimated 32 by doing the radius and cut it down a bit. Genius right there. You don't even have to solve the problem. You can just get an estimate and then you know what the answer probably is going to be, right? So just one moment. One moment, everybody. One moment. Okay. So first, let's do the straight lines. Personally, I think it's going to be easier to do the straight lines, right? So what is the length of the straight line? Well, you'll notice that it's the length of half of a circle plus another half of a circle. Well, half of a circle is 2 inches. We can see that, right? That's called the radius. So 2 plus 2 is 4. So this straight line is 4. This one's 4. This one's 4. This one's 4. 4 plus 4 plus 4 plus 4 is 16. We're already at 16, so it's not A, it's not B. Okay. So it's either going to be 21 or 29. Now, the question is, how long are these little circle bits? Well, remember, they all add up to one circle. Now, what is the formula? This is just a formula you'll have to know for the circumference of a circle. There's two ways to write it. You might know it as pi times d. D is the diameter. Diameter is all the way across the circle. But a diameter is just two radiuses. It's two half circles. So that's why you might also know it as 2 pi r. They put the 2 in front of the pi for some reason. I don't know. They just decided to stick the pi in the middle. I don't know why. But the reason why this is also the formula is because 2 times r is just d. They're the same thing. So the way you use a formula is you just plug in the letters you know. 2 times pi is 3.14, always 3.14. And then r is the radius. The radius is 2. That's what the problem gave us. So we can multiply these numbers first, right? 2 times 2 is 4. And 4 times 3.14 is going to give us 12.56. So in total, we have 16 for the straight lines, plus, I'm going to color code this for some reason, plus 12.56. Now it does say to the nearest inch, so we're going to have to do rounding. So 12.56, that rounds to 13, right? Because this is a 5, so it rounds to 13. 16 plus 13 is 29. That is answer choice D. So I know this was kind of a weird problem, but you just want to break it down into manageable components, manageable steps. Hey, you're like, how do I find the length of a weird shape? Break it down into smaller shapes that you do know how to solve, and then just add them together. Now, obviously, I can't imagine that you guys are going to go to the ACT and then have to find the perimeter of a square circle. That's probably not going to happen. But I have seen multiple of these weird geometry problems where it's like solve this and solve this and solve this and like weird things that you probably never learned in school. So I just wanted to get you used to what that looks like. What is the thought process behind solving a problem like this? It may look totally different when you do it, but now you know how to mentally prepare for it. You're like, okay, how do I break this down into little components? Uh, Even go back to, it was problem number 4 in this live stream. If you weren't there in this stream for that problem, it was kind of similar to this, where there's multiple steps in a diagram. Start from the end. What am I solving for? How do I get there? That's the thought process you want. Yeah, getting experience for like internships and stuff for resume is pretty good. That even that is hard too though. So the 4 curves create a single circle. Yes. So even though they're completely disconnected from each other, it doesn't matter because all of the circles are the same size. So in total, these 4 corners all make one circle. And you can just see that visually, right? Like this is a quarter of a circle, that's a quarter of a circle, quarter circle, quarter circle, right? It makes one full circle. So, you have to like extend your brain and think creatively to even realize that you're supposed to just use the circumference formula because you might not even think to do that. But even though they're all disconnected from each other, they still just make one circle. Can you go over some formulas perhaps? Sure, I can do that real quick. Headed out. Have a good night, everyone. Good night. Get some good sleep for the test. Thanks. Good luck tomorrow. Good luck, everybody. Yeah, get some good sleep, everyone. We're basically done. I want to go. Because the person mentioned formulas. Actually, let's not erase it. Let's keep that there. Let's just go down here. I don't think there's that many formulas that you'll need to know. I do think the ACT is a little bit ruder when it comes to not giving you formulas because the SAT, I think it at least when I took it, it just gives you a formula sheet for the most important formulas. I don't think the ACT gives you anything like that. But I mean, honestly, just the basic ones off the top of my head are just areas and perimeters of things. Remember, perimeter is always just all the lengths around something. So technically there is a formula for the perimeter of a rectangle. It's like 2 times L plus W. but you don't even necessarily have to like don't memorize that. Just know that perimeter is all the lengths around. Now, area, it is more helpful to know. So, for example, a rectangle area is length times width. That's a pretty standard one. A square is basically the same thing. It's length times width. The only reason you see squares with different formulas is because they're all the same length. But if you want to completely ignore that and just use the same formula for a square, go ahead. I have testing tomorrow. Could we go over some probability of like students and grades type problems? Um, I mean, if you have like an example that you can give, then yeah, I can go over something real quick if you want. Uh, trapeziums, is that the same as a trapezoid? Trapezium? Um, yeah, I think that there's probably a formula for that. I mean, honestly, even if you don't know a formula, so that's actually a good example. Let's say you have, and I don't know if this is the same thing as trapezium. I don't know if it's the same as trapezoid, if that's just another name. But like, for example, let's say you had this and you had to find the area of this. You might be like, well, I don't know what the formula is for that, right? Well, what can you do instead? Well, you can kind of just think about what do I already know? Uh, okay, yeah, good. It's the same thing. Okay. So, like honestly, if you were to ask me off the top of your head or off like how do you find the area? I don't there's probably a formula. I don't know the formula. But what do I notice about this shape? It just looks like a weird stretched out rectangle, right? Like if I were to draw a rectangle like this, if I had a rectangle like this, and then I just like stretched it out so that the bottom's bigger and the top's smaller, it looks like it's the same shape, right? And that if you like stretched it out like that, it would be the same area. So we might not be able to get like a super exact answer, but this is how I would find the area, even if it's not exact, especially because it's a multiple choice. And multiple choice, you can just pick whatever is the closest answer. So that's how I would find the area. Like, for example, let's say this was 7 and this was 9, and let's say it's 4 tall, right? Well, I would just imagine there being a rectangle here. And well, if the top is 7 and the bottom is 9, then this imaginary rectangle would have a height of 8, right? That's the number in between 7 and 9. And length times width, 8 times 4 is 32. So I would say the area of this is 32. And I believe it is exactly 32, as far as I know. But like, even if you don't know the formula or how to solve for something, then this is a good way to just think, like, even if it's not the exact answer, just to do a sanity check on the answer. Just be like, what answer makes the most sense? Log formulas, I do have a video. I have videos on logarithms that might be helpful if you want to go over that. I don't think it's that often on the ACT, but I do have videos if you want to watch those for logs. The only other important formulas, I mean, triangles, I guess. Triangles area is 1/2 base times height. That's a pretty important one to know. And then circles are probably like if you're gonna memorize any formula, I mean, I'm not a fan of memorizing formulas, but if you're gonna memorize anything, memorize the circle formulas. I'm not gonna lie, you're so underrated, man. Thank you. I will tell all my friends about you. Let's go. Let's go. Thank you. Thank you so much. I appreciate it. We can also split into 2 triangles and 1 right. Okay, that's probably the exact way to do it. Yeah, is to split it up into. Yeah, that's probably the technical way to do it. So you can do that as well. Like I said, there's almost always more than one way to solve a problem. Okay, I teased earlier, like if you're going to memorize anything, memorize the circle formulas, right? 2 main ones. Circumference is just the perimeter, it's all the distance around, but for some reason they were like, let's call it the circumference because to confuse everybody. Okay. And then we have the area. I guess they didn't want a fancy name for area. So circumference is pi times the diameter, right? Or 2 pi r. Just memorize whichever one you think is easier for you. Just know that the only reason you can do both is because diameter is all the way across. Radius, r, is just half of the way across. So 2 half of the ways across is the same as all the way across. So that's why you have two options. Area is pi times the radius squared. So really, I mean, if it helps you memorize, you can just think of these two because they're basically the same. It's just the location of the two is different. And you can know that area is the one with the exponent because area is always in square meters, right? When you're finding area, you're always finding it in square amounts. So that's why it's called square. That's like why it's called that. So area is going to be the one with the exponent. Should you go over probability? Like what's the seventh? Well, those are two different things. The seventh digit from the right of the repeating term uh, is not, I mean, that's not probability, but I can go over the repeating term thing. I think I actually went over it in a previous live stream, but the fact that multiple people are asking about it, to me, that seems like a sign that it's pretty popular on the test. So it must be tripping a lot of people up. So I will definitely go over that right now. Let's just do that exact example 1563, and it says find the seventh term, right? And this keeps going on. Now, I would assume that if you had this problem on the test, it would have a bar over some of the numbers. Oh, I'm cooked. I said probability when it's not. I mean, honestly, vocab terms, who cares, right? I don't care about math vocab terms. There's a few that you should know. Other than that, like, who cares what things are called, right? That's not really what the ACT tests. It's more about they honestly sometimes they try to scare you with vocab terms, but really it tests your skill and not necessarily how eloquent you are in math. Like who cares? I try to avoid math vocab as much as possible on this channel. It's like who cares? It's just confusing. Bye everyone and good luck. Bye. Good luck. Okay. So if you were to do this problem, right? It's probably going to tell you which digits are repeating. And usually they do that with a bar on the top. Obviously, I don't think you can type that on YouTube chat. But let's say that it just said the 6-3 is repeating. Well, if it has a bar over the 6-3, that means it's going to keep going 6-3, 6-3, 6-3, and so on, right? And then seventh term, or did you say term or digit? Oh, digit. Sorry, not seventh term. Seventh digit. Uh, well, that would be 1, 2, 3, 4, 5, 6, 7. This is the seventh one right here, 6. Um, let's say it asked for something crazy. Let's say, what is the 100th digit? You're like, am I supposed to write out 100 numbers? Well, no, you don't have to, right? Here's the 5th, 6th, 7th, 8th, 9th, and 10th, and so on, right? So you might notice something. On all of the even numbers, it's 3, 6, 8, 10. It's always 3. For all of the odd numbers, it's always 6. Do you teach English and reading for the ACT? No, unfortunately, no. I'm not a fan of reading problems and stuff. I'm more of a math guy. So I don't really go over the reading problem. Maybe in the future. Maybe in the future I should, just so I can get full ACT review videos just on everything. But I feel like I wouldn't be as much help because I don't really know how to explain it. I feel like math is just what I'm best at explaining, so that's why I do it. So let's say it asks for the 100th digit, right? Even numbers are always 3, odd numbers are always 6. So if it says for the 100th digit, that is an even number. So it must be 3. That's how I would think through a problem like this. Is just like just using these little context clues like this. Okay. Someone requested something. Um only 10th, 11th, 12th graders attend Washington High School ratio. Total student population if one student. Students total population is yikes. That's a hard one. Oh, actually no, it's okay. You know what? It's not that bad. It looks scary when you, especially when you see ratios. Ratios are basically the same thing as probability or fractions. So basically, here's what this person's saying in this problem. Let's go ahead and do this real quick, and then I might call it a day unless anyone has any other questions, or if you guys just want to chat, I'm open to chatting. So it says there's 10th, 11th, and 12th graders in a school, and it's saying the ratio of 10th graders to the full student population is 86 to 255. And you might be like, why are you writing it as a fraction? It was a 86 colon 255. You can't do that. They're actually the same thing. Ratios are and fractions are, I mean, they're not exactly the same, but they're basically the same thing. So uh, we don't know the amount of students in the school, but we can imagine that there are 255 students in this school. If there were 255, then 86 would be in 10th grade. What was the other number? 18 to 51 for 11th grade. And we don't know anything about this. So it says, if, okay, now and then it goes like, what if you picked a student at random, then what would be the most like, basically it's asking, because what's grade is going to be the most likely, the one with the most students. So it's basically asking what's the most students, but in the most complicated way possible. Well, what can you do with fractions to compare them? You could try to get the same denominator if you really want to, but why don't we just turn these into decimals? And you can do that just by dividing. So for 10th grade, 86 divided by 255 is 0.337. Remember, fractions are the same thing as division. That's an important thing to know. 18 divided by 51 is 0.353. Now, we don't know what 12th grade is. Uh, if you want, honestly, you can already call 11th grade the answer because this 3.333 is a third, right? If it was even, it would be 0.333 for every grade. In this case, we have about a third for 10th. We have a little bit more than a third for 11th. So that means 12th is going to be a little bit less than a third. So 11th has to be the highest. If you want to do all the work, we can go ahead and take, because 1 is going to be the total amount for all of the ratios. If you want to find out what 12th is, what 12th grade is, just do 1 minus 0.337 minus 0.353. That is going to leave us with 0.31. I mean, it ends there, but there's a 0 after that technically. So if you want to do all the work, you can do that. As a sanity check. I mean, if you have time, you can do the full problem out. It always helps. Doesn't hurt. Other than that, you're losing time. But if you have time to do it, then why not? So, I mean, said which is the most likely? It's going to be the one with the most students, and that's going to be 11th grade. So remember, ratios, fractions, division, they're all kind of just different words for the same thing. Okay. Um, oh, and oh yeah, and I also noticed the problem I just did. He said that option E is cannot be determined from the given information. That's almost always wrong. That's almost never going to be the answer. I don't know if they even put that option anymore because they just got rid of option E recently. There's only A, B, C, D. So if you guys are planning on guessing for all the problems, you have a better chance now. You have a 1 in 4 chance instead of 1 in 5. Do you think factoring or quadratic formula is better? Factoring is so much better, but only if it's possible. The problem with factoring is that it's not always possible. So quadratic formula always works. So what I do is I see if I can factor it just at first glance. If it's not factorable, then do the quadratic formula. Also, quadratic formula, I feel like you're more likely to make a mistake too. It's really easy to make a little math error. So that's why factoring is safest and fastest if it's possible. And I feel like the ACT, they'd probably write questions with that in mind, like um, purposely making it factorable. Let's see. How's it going? Love the videos. Rising Junior who took the ACT last October without studying and got a 30. Wow, nice. without studying got a 30. That's crazy. 30 math and 33 reading. Don't worry about English. Uh, well, I mean, if we do some calculations, 30 plus 33, you probably got a 27 on. I mean, that's still really good, honestly, without studying, especially. What is the best way to get from a 30 to a 33 math? I mean, it might sound boring, but I'm just gonna be like, do practice problems. I mean, like that's honestly that's the best way to study. Other than that, math is just, especially on the ACT, is very much just about uh like just math skill and just thinking logically through problems. So if that comes naturally to you, then great. I mean, I would imagine it might because you have a 30 on the math. So that proves that you've got that those math skills. Um, but uh yeah, I mean, just look at different practice problems. If you're at a 30, then I would say uh I don't know if you've already looked at the official ACT practice tests, but go on those and skip to the bottom. Go look at problems like 41 through 45 or maybe in the 30s and see if you can solve those problems because those are where they get obscure and weird. That's what I would do. Is this pre-recorded? Yes, this is pre-recorded, and I am predicting everything that you're gonna say. Uh, no, we're just hanging out live. I just got here. Welcome. Let's see. I probably don't. When it comes to the math section, that's the one I'm most worried about. What should I remember most to be able to get a decent score? Um, the formulas we just talked about, if you want to rewind like 10-15 minutes, we talked about formulas. Just I'm not a big fan of memorizing formulas, but there's a couple you should know, so you can go there. Circle formulas, rectangle, stuff like that. Other than that, just maybe if you want, because I know it's getting late and the ACT's tomorrow. If you want to do just real quick, just so you have an idea of how fast you should be going on the test, maybe before you go to bed, say pull up 10 practice problems and give yourself 10 minutes. Start a 10-minute timer, do 10 practice problems, and just see how it feels to do a problem per minute. If you can do that, then that's going to give you an idea of how fast you should be going on test day. It would only take 10 minutes and it might help you a lot just with, because if you think about it, if you've never taken the test before, if you're like, I need to do a problem per minute, you don't really know what that feels like instinctually to do a problem per minute. It's really easy to lose track of time. So just having that feeling of what doing a problem per minute feels like is going to be really helpful. Sorry, there's uh probably so many things. I don't know why I'm going so far back in the chat. Uh, answering questions speed run. Do you think the new format is better than the old format? Less questions, more time, so yes. Uh, we show an example of a factoring or quadratic problem. I believe there was one earlier. I don't remember if it was. No, I was about to say 6 or 7, guys. I'm sorry. It was problem 6 or 7. No, why did I say that? I think it was 6. There was one earlier. You can rewind and see that. Horrible at English. I mean, yeah, English isn't my for the English part of the test is. I mean, I'm kind of average. The reading is the worst. I feel like grammar was always my middle ground well, I took the SAT, not the ACT, but like the grammar was always my like middle. It's like it's not so weird on the which is the best answer. It's not so subjective. It's kind of like math where there are rules and there's like an objectively correct answer. So, I mean, honestly, grammar questions I kind of like. They're not bad. You need to change the channel to grammar. I did competitions as a kid, but I don't like studying. Well, I mean, you've got that the skill already, and it's not like a test in school where you need to study specific things. I mean, yes, studying is good, but a lot of it just comes down to knowing what it feels like to do a problem, having the skill to just pick apart a problem. How do I solve this? So it's not like studying. I mean, studying is important, but it's not like you have to memorize problems per se. The only reason I do these problems is so that you guys know what it feels like to do a problem. and you get practice solving a problem and thinking through one. It's really to train your brain muscles more than it is to shove specific math topics into your brain. That's my opinion of why I do this. We've got a probability problem. Why you not solve my problem? Please, I need it. Hold on, let's look at the problem. Maybe I can do how many additional red marbles? Um, I feel like the probability problems are typically kind of the same-ish. Uh, but just I probably won't do the full problem, but just like um I think the probability problem I did earlier might help. Actually, we might have time to do that. Let's go see what the other problem was, and then maybe we'll get to the marble problem, and then we can call it a day. What was the other one? What is the sum of k equals 0 to infinity 7 minus 8 raised to the k? Oh, how do you do that? Okay, so I think I know what he's saying. Basically, was that really on the ACT? Oh, I feel like there's a way to solve this that I'm trying to remember. There's like a way to do this. Basically, what the question's asking, if you want the technical way to do it, I think it's like it looks something like this. I don't know. It's like the weird like sigma symbol. But basically all this means is if you were to take -7 over 8 to the 0, wait, sum to infinity plus -7 over 8 to the 1 plus -7 over 8 to the 2, like on into infinity, what does it equal? I'm sorry, I don't actually know how to solve. I'm not really sure how to do that one off the top of my head. What did the person say the answer was? Someone solved it in the chat. Yo, thank you for so much. I'm heading out. Thanks for everything again. Thank you. And yeah, get good sleep for the test and good luck on the test. I can't believe, was this really an ACT problem? That's crazy. Okay, if you use the sigma notation in your calculator and you get 8 over 15. Yeah, I'm sorry. I wish I was more help for this problem. There's no way. Unless there's something that I'm totally missing here. Like that would make this a lot easier. There's probably some way to solve this that I'm missing. That's crazy. I'm like racking my brain trying to think of an easier way to solve this. Because obviously you're not just gonna, I mean, okay, one thing you can do is you can just start putting this in your calculator, solve each one. I mean, this would take a while, but solve each one up to like 4 or 5 and see what it's trending towards. Because eventually, even though it goes on infinitely, you're going to get closer and closer to the final answer each time. And so you can kind of tell that it's like, for example, 8 over 15. What is 8 over 15 in decimal? It's 0.53333, right? Okay. So let's say you do this a few times and you end up getting 0.53332. Then you might be like, okay, I have a feeling I know what the answer is, right? So if you don't know how to solve it normally, you can brute force it, but it takes a long time. So honestly, if I saw this as an ACT problem, this is the first thing I would do because the longer you take to try to remember how to do something, the more time you're going to waste. So yeah. So sorry I wasn't more help for that problem. Okay, let's do the marble problem. I think it's important. I think that I don't I yeah, probability if you take some time to learn how it works, I feel like it can feel really logical and it might even be the easiest problems that come across. But you have to know how to do it first. And I understand why it's scary is it's because no one really teaches it in school for most students. So it says a bag contains 12 red marbles, 5 yellow marbles, and 15 green ones. And it says how many additional red marbles So we are adding some amount to the red marbles so that the probability of randomly drawing a red marble is 3 out of 5. Okay, so we want the chances of drawing a red marble. Let me bring the chat back down so that I can read it. I always get the most wrong in stats and probability. I mean, honestly, it might be the least varied category. Like the problems all kind of feel the same. So I would say just, I mean, I always say just do practice problems, but like if you just get used to what the basic rules of probabilities are, fractions are really important. Knowing fractions and decimals and how they relate to probability, and know that two events happening at the same time multiply the probabilities. If you just get the hang of doing a few different probability problems, the goal is to make it feel natural. Like, for example, a coin flip, we all know a coin flip is one half, right? Flipping a coin. Now, what's the chances of doing it twice in a row correctly? Well, you might kind of know like, instinctually it's about 1/4. How do you get that? One half times one half. So it's kind of ingrained in our brains already. You kind of just have to like summon that knowledge, you know? I mean, that's some weird advice from me, but yes, that's what I would say. The goal is to make it feel logical to you. Thank you, heading out. No problem. Bye. Good luck on the ACT. Um, so how do we get 3/5 for red? Well, the thing is, what is not going to change? What's not going to change is the amount of yellow and green. In total, that's, well, really, it doesn't matter how much is yellow and how much is green, because all we know is that they're not red. That's what matters. So yellow and green, 5 plus 15 is 20. So there's 20 that are not red. So 3/5, honestly, the first thing that comes to mind is let's think about it visually. Let's draw ourselves a pie chart and let's split it up into 5 different sections because they're fifths, right? We want 3/5 to be red and 2/5 need to be not red. Well, not reds are never going to change. Not reds, it's always going to be 20. So how much do we need to put in each slice? 10. 10 not reds in each slice, which means how much needs to be red? Well, 10 plus 10 plus 10, 30. So if we have 20 not reds, we need to have 30 reds. We need 30 reds total for it to be a 3 out of 5 chance. So now what's the question asking? How many red marbles do we need to add? Well, we already have 12. So how many do we need to get to 30? 30 minus 12 is 18. So honestly, kind of a visual representation is what makes the most sense to me for this problem. But if you want to do like multiplying fractions, dividing fractions to solve this one, you can do that too. You don't have to draw stuff on the ACT. Okay, let me know if anyone has any other questions. Uh, we've kind of exhausted all the questions for today. And looks like it's been over 2 hours. Time flies, I guess. So if anyone has any other questions, let me know. And if not, then good luck everyone on the ACT. I'll go ahead and leave this up here. I shouldn't have erased it. Someone's asking, why is there 10 in every piece of the pie? Because the way we got 10 was that we knew that there were 20 not red marbles. Now, we don't know how many red marbles we need, so we're not going to worry about that, but we know that there are always going to be 20 not red marbles. The problem does not let us add yellow or green. And we know that if 3 out of 5 slices are red, 2 out of 5 have to be not red. The other 2 have to be not red. If there are 2 slices and we have 20 not reds, then there must be 10 in each slice. 10 plus 10, 20. So that's where the 10 came from. Pray that my reading score saves me. Yeah, my reading score was definitely not the saving score for me. It was for when I took the SAT. I did better on the math. The reading score was what lowered it more. Thing about the ACT is if there's one section that you don't like that much, it's not gonna like kill your grade. Because like on the SAT, it's just all the English stuff, and then math, and each is one half. On the ACT, it's three sections. There's reading, grammar, and math. So if you're not a fan of math, on the ACT, it's only a third of your grade. Well, thank you. No problem. Wish me luck tomorrow. Have a great night. Good luck. You got this. All right. Well, I think I'm gonna head off now. Hopefully you guys are all ready. If you still want more practice and, don't care about sleep, then you can I just posted like a 2 hour video. It's crazy how that does really good because that's just all my other videos like combined. So there's a 2 hour ACT review that's just all the ACT videos I've ever made into one that was posted recently if you want more practice like this. And it will be a little faster paced than this. I know we're going really slow with this. There are a lot more than 10 problems in that video. Um, so if you want more practice, you can take a look at that. Otherwise, get some good sleep and make sure your brain cells are ready for the test. I watched all of that today. Whoa, all of that with 2 hours of math. Good job. It's always crazy because right now my most viewed video it was also a compilation of just like previous videos. It's like full algebra course or something, and it's like 10 hours long. And like somehow that's the most viewed. Like I want to know the one person out there who's actually watched that entire thing. Maybe they're watching the stream right now and they want to reveal themselves. But like it's crazy how much people just love like these long videos that just like go over everything. I mean, I get it because like you want to have the comprehensive guide. You don't want just like little bits and pieces. You want to know that you're doing it. Where you get your practice questions from? I pretty much pull I look at the official ACT practice tests. I just got a book that's official ACT, and then I create questions based on that. So like I'll, change the question a little bit so that it's like a new question, but they're heavily inspired from the official ACT questions. So that's where I get the practice questions from. So if you're wanting practice questions to do, I would suggest, um, yeah, official ACT practice test. Just, I guess if you just Google that, it will probably be the first result. They've got two versions. They've got the full length test on like just like PDFs, and then they've got like the cheesy video game version that are just like little 7 question quizzes. It looks like what someone thought a video game looks like. I think I did a video where I did one of those, and of course I'm just like making fun of it the whole video. But um, imaginary numbers, that's something I should be worried about. It is a tested topic. If you want to learn it real quick, I mean, I actually do have a video on it. I think it's probably just like 5 minutes long, 5 to 10 minutes. If you don't know how imaginary numbers work, they're actually not that bad. But yes, they are a tested topic. I wouldn't like worry about it per se, because any individual, like even just like worrying about a specific topic, like any specific topic probably isn't going to show up in more than 2 or 3 problems. But um, if you, it is on the test. So if you want to learn how that works, then I would recommend looking it up, especially if you're like interested and you're like, I feel like I am weak in this area and would like to know more about this. That is a great way to study, but if you know your weak points. Okay. Well, thanks for watching, everybody. I think I'm gonna head off, and good luck, everyone, on the ACT. When was it uploaded? I mean, honestly, it's kind of an old video, but I mean, you can just search up number nerd imaginary numbers if you want. Uh, or honestly, even if you like sorted my videos by oldest, you might be able to find it. But yeah, I would just search up. It's just called just sort of imaginary numbers, number nerd, or someone else's video that works too. Uh, yeah. Good night. Thanks for watching, everyone, by the way, because uh, it's not. I mean, it is just kind of a chill stream, but it takes brain power to be sitting through this and trying to comprehend the problem. So you guys are putting in a lot of work. So good job. And yeah, all right, I'm gonna head off. Bye, everybody. Let's put the screen thing on. There we go. All right. Thanks for watching and good luck, everyone.